All right, ladies and gentlemen, today we're going to look at solving quadratic equations, section 12.4. All right, so this is our first time looking at actually solving a quadratic. So we've been dealing with quadratics quite a bit. We were factoring them before Christmas. Now we've been looking at graphing them, standard form, vertex form, but this is our first time actually solving a quadratic. All right, so when we solve, a quadratic has what we call solutions, which makes sense. We also call these on a quadratic, we can also call them roots or x-intercepts, okay? So solutions, roots, x-intercepts are all interchangeable terms when we were talking about quadratics. Now, for a quadratic, it has three options. All right, so any quadratic, I'm just going to draw an xy axis here, can either have one solution, and this occurs when that quadratic is graphed and the vertex falls right on the x-axis there, okay? So that vertex is right on the x-axis. Could point up, could point down, but that's going to give us one solution. We can have two solutions, and that is when our vertex is above and it points down, or maybe below and it points up, but we see we cross the x-axis in each of these cases 2 times. Okay, so those are our x-intercepts or our solutions there. The third case is when we have no solution. And this is, say my vertex is above, but it points up, or below, and it points down. So in these cases, my graph never crosses that x-axis there. All right, so those are my three types of situations. I'm either going to have one solution, two solutions, or no solutions. So let's take a look at what this looks like actually solving one of these here by graphing. All right, so we're asked to solve x squared plus 6x plus 8 equals 0 by graphing. Right? Well, we know how to graph, right? This is in standard form. Okay, so I want to find my vertex. Well, that's x equals negative b over 2a. So negative b, which is 6, over 2 times a, which is 1. So we get a vertex, negative 6 divided by 2, negative 3. All right, the y that goes with that, we know we get that by plugging that back in. So negative 3 squared plus 6 times negative 3 plus 8. So we're going to get 9 minus 18 plus 8. So 9 and 8 is 17 minus 18. So there's negative 1. So we have negative 3, negative 1. Right, so let me plot that point. Negative 3, negative 1. So we are right there. My a value is positive. This is going to point up. So since my vertex is below and it points up, I know I'm going to have two solutions here. My vertex is not on the x-axis. So now I need to find that next point so I can see where this crosses that x-axis. All right, well, we can make our 3-column t-chart here. So x, y equals x squared, and then my third column, ax squared. Well, in this case, a is 1, so this is still just 1x squared. 1, 2 here, and 1, 4 here. And my third column will be the same as my middle. So now we want to plot the points 1, 1, and 2, 4. And remember, we plot those from our vertex, so nothing new here. All right, so go 1, 1, and 1, 2, 1, 2, 3, 4. Okay, reflect those points over. Draw my parabola here. Preferably have it go through the dots. All right, and then we say, okay, where does this cross the x-axis? Where does this intercept the x-axis? Well, it intercepts the x-axis here and here. So our solutions to this are x equals -2 and -4. So that's what we mean when we say solving by graphing. Graph it. Where does it cross the x-axis? That's our solutions. And the solutions specifically are the x values. That's why we call them x-intercepts. All right, the next type of solving that we're going to look at in this section is solving using square roots. Solving using square roots refers to these types of problems here. So we have x squared equals 16. Okay, well, I believe we talked in that earlier section actually here about like opposite operations. Right, so we know addition, subtraction are opposite. We know multiplication and division are opposite. And we talked that squaring something and the square root are also opposites. Okay, so here I'll take the square root of x squared and the square root of 16. Well, the square root of x squared is x. The square root of 16 is 4. But there's one extra thing that we got to remember on this piece here, is when I take the square root of a variable squared here, and I have that number, okay, that I have to add this plus or minus in front. All right, so that plus or minus, and what that's telling me there is that both +4 and -4 are solutions to my original equation there. Because x squared, I'm saying x squared equals 16. So I know what value squared equaled 16. Well, 4 squared obviously equals 16. But we also know that -4 squared is going to equal 16. So that's why I have to add that plus minus there. All right, we can also use this technique to solve equations like 3x squared equals 27. All right, so our first step here, well, first we want to start by dividing by 3. We get x squared equals 9. Now, I'll take the square root of both sides, and we are left with x equals, again, need that plus or minus, square root of 9 is 3. All right, last type of example here. X squared minus 25 equals 0. Okay, again, first step, add 25 to both sides. X squared equals 25. Now I can take the square root of both sides. Square root of x squared is x. Square root of 25 is 5. And don't forget my plus and minus, because I need those two solutions there. All right, that does it for this section.